What's up guys, welcome back to the channel. Today we're going to be going over how to weld aluminum. Welding aluminum is very different from stainless steel, mild steel, titanium. It has a few little quirks that you need to pay attention to in order to get a good result. So we've got a lot to go over. Not going to waste any time. We're going to jump right into the video. I've got a few pieces of 16 gauge aluminum tubing here that I just cut up on the bandsaw, and they aren't perfectly flat. So the first thing we'll want to do is take them over to the belt sander and face them off so that we have a nice tight fit between each piece and no gaps. The belt that's currently on the sander has been used on steel, so before we start cleaning up our aluminum, we'll want to switch out the belt to a fresh one so we don't cross-contaminate. Always wear your safety glasses, and gloves are nice, especially on aluminum, because that stuff gets hot really quick. This is a 4x36 Ryobi belt sander from Home Depot. Works pretty well, except it is a little annoying on this 4-inch tubing. Having a 4-inch wide belt slows me down a little bit. Eventually I want to get a wider one. This one's a good starter though. Now that our pieces are nice and flat, we can deburr the outside, also on the belt sander, and then deburr the inside with a deburr tool. When deburring with a belt sander, remember, you're not trying to put a bevel on the part, you're just skimming that corner off to get rid of the burr. Now that our pieces are nice and flat and they don't have any burrs, we can begin the cleaning process. Our next step is going to be to take a stainless steel wire brush that is clean and dedicated to aluminum, and wire brush our joints inside and out, again to go at that oxide layer and get off as much as we can. On brand new high quality material, you may not always have to wire brush. An acetone wipe alone may be sufficient, but it can't hurt. Every time I have helped someone learning to weld aluminum, their biggest issue has been that their parts are not clean enough. Our next step is going to be to take some acetone and wipe down our pieces, as well as our filler rod. We're using 3/32 4043 aluminum filler rod. 3/32 is the best one to use for 16 gauge. My rule of thumb for aluminum filler rod size is to use one size larger than your material thickness, which is a difference from steel and stainless, where the rule would be typically to use one size smaller than your material thickness. Aluminum does like to have a good bit more filler, which is also helpful for keeping it cool and preventing cracking. If you don't have enough filler, it is very prone to cracking. We're going to take this stuff, wipe it down, and I'll just show you what comes off just the filler rod. Very important to clean your filler. That bit of dirt would have a pretty large effect on your weld quality, your control over the puddle, and I'll wipe this down until it comes off clean. And there you can see that's just from one side of this piece, just aluminum dust from previous cleaning, just what it has on the surface just naturally. And as we get a piece of rag that's dirty like this, flip it over to a clean side or toss it out. The next step after we've wiped everything down, I'm going to take this blowtorch and just hit each piece quickly to watch the water evaporate off. Aluminum is porous, and if you leave it just as it is, it will have moisture inside the material that can affect your weld quality. You will be able to see as soon as you hit the pieces with the flame, you'll see the water clear out and come off. While these parts cool down, I'm going to teach you guys about AC current and how AC balance and frequency work for setting up your welder. So to explain how AC works, I first need to explain to you how DC works, which is what you use when you weld steel, stainless steel, titanium. Your torch lead on your machine is in the negative slot, and your ground lead is in the positive slot, so remember that. DC stands for direct current. The current always flows in one direction, and the current always flows from the negative to the positive. So when you're set on DC with your torch in the negative and your ground in the positive, the current is constantly going in this direction. Torch to workpiece and then to your ground, and it continues in that cycle. So you can imagine if this is flowing into your part, that is where you get the penetration effect when you're welding steel. To have enough penetration, you have to have enough current going into the part, among other things. When you switch over to alternating current, your torch and your ground switch places every so often. The torch will start off as negative and it'll alternate, switching your torch from negative to positive and negative to positive, which alternates the direction of your current. So instead of flowing one direction, it comes back and forth. This is required for aluminum because of that oxide layer I was talking about. If you just had DC current on aluminum, your current would flow this way, but that oxide layer would prevent it from getting into the part. So when you have alternating current, the current flows this way and breaks that oxide layer so that it can then flow this way and penetrate into your part. We're gonna go ahead here and turn the machine on. I hope you guys can still hear me. This thing is a little bit loud. In order to weld aluminum, you'll have to set your machine to AC. We've got our amperage. We're not gonna use pulse. Our AC balance is reading at 60. We're gonna turn that up to 70. One thing to be aware of is that some machines read in electrode negative and some read in electrode positive. You'll want to look that up on your machine before you go into these settings. When I set this machine at 70%, I am setting it for 70% of the current to come from the torch and 30% to come from the ground clamp. What this does is makes 30% come out of the part, 70% go into the part, which gives us 30% cleaning, which removes that oxide layer, and 70% penetration when it's penetrating into the part. If you've ever heard of someone balling their tungsten for aluminum, the reason that that happens is because now instead of being on DC and having all of your current going out of the tungsten, now you have a percentage of your current coming towards the tungsten, and the force of that current flowing towards the tungsten rounds that end off. The reason for changing that setting is to have more cleaning or more penetration. When you have more electrode negative, you have more penetration and less cleaning. When you have less electrode negative, you have less penetration and more cleaning. If you have really clean material, you might set it at 80% electrode negative to have a lot of penetration, and you don't have to clean that material too much, so you don't need the cleaning effect as much. When you have really dirty material, you might set it at 60 or 65% electrode negative so that you have more cleaning effect to clean that material better, but then you'll get a little bit less penetration. If you guys have any questions on that, drop it down in the comments. I typically like to run 70% on clean parts. It just is where it feels like it runs the best for me. Now, to explain AC frequency, it's basically just how frequently that current alternates. So the faster it alternates, which would be a high setting, is a more focused arc, but less heat. So it'll frequently be changing between there, and so it doesn't give as much time to get the heat into the part. When you set it lower, it will switch more slowly, and you'll get more heat into the part, and you'll get a wider weld. When you're doing some really precision thin work, you might turn it up. If you're doing some heavier work, you might turn it down. I like it right around 140. Now we're ready to tack up our parts. One of the nice things about aluminum is that that oxide layer protects the inside of the puddle, so we won't need to purge the part. As I told you, aluminum likes filler rod, and without enough filler rod, it likes to crack. Fuse tacks, when you're tacking your part up, can be difficult, so I like to run a short fusion weld, and even then, sometimes they still crack, but it's enough to hold it together so that we can get our other hand free and add some tacks with filler. You can see we're starting up here and getting our puddle up to size with full pedal as quickly as possible so that we can get moving and not overheat the part. Aluminum will heat up very quickly and spread that heat throughout the part, so you will definitely have to let off the pedal as you go on each bead to keep it consistent in width. That does make it a little bit difficult, but just be cautious of that and watch the width of your puddle and adjust your foot pedal amperage accordingly. With this 332 filler rod, we're adding just a quick dab. If you add too much, it will cool your puddle off and you won't get enough penetration. The method to know that you are getting the correct amount of penetration, as you can see very well in this video, is adding your filler and then stepping forward and watching that puddle sink. That sinking that you see in the puddle, is it falling through and penetrating? Once you see that sink, you can add your dab and then repeat. If you're not seeing that puddle sinking, it's usually a sign that you need to step forward a little further before adding your dab of filler. That's another little difference from aluminum to steel or stainless steel. It likes that further step, and that is why on really nice aluminum welds you usually see that very pronounced dime pattern. That is from stepping out quite a bit further than you do on steel or stainless. And now I am switching over to some bonus welding of an aluminum donut from Alucon, which is a branch of Stainless Bros. I picked one of these up just to try it out. They're really handy for getting tight radius bends. I also wanted to add this video to show you guys an example of what to do when you finish a weld. At the end of an aluminum weld, they're very prone to getting fisheyes or pinholes, so you want to add a couple extra cool dabs of filler to avoid that. And also make sure to let off the pedal extra slow. Now that we're done with this, we will take a look at this aluminum donut and see the final product. Before we take a look at our donut, I want to tell you guys about my Lincoln Square Wave TIG 200 welder giveaway. This is the welder that you just watched me do all of this aluminum welding with. I'm going to be giving this welder away because I'm upgrading to an Everlast welder, and so I want to help someone out. If you're interested in getting entered in this giveaway, check the description down below for instructions on how to get entered. It's completely free, costs you nothing. And if you're in the United States, I'll ship it to you for free. If you're looking for more support in your welding and fabrication journey, take a look at my SKOOL community. I will also link that down in the description. It's basically like a Facebook group where you can post your welds and other fabricators like myself can comment to give you advice on how to improve. I post cool welding tips and tricks in there daily, so give it a join. There may also be exclusive content and more giveaways available on there in the future, so check that out. I hope to see you guys there. If you're looking for a brand new welder and you'd like to support the channel, I've got a link down in the description for Everlast welders. If you purchase a welder from this link, I get a small portion of it, and you get an upgraded foot pedal and TIG torch. Everlast is the best quality welder that I've seen for the price. You can look that up. People love them. Even if you don't use my link, that's who I would recommend. And that's the reason that I'm getting my next welder from Everlast. And now let's check out our donut. All right guys, so here's our donut. And what you can do is basically cut this thing in half or in quarters, and then you get yourself a really tight radius bend that can't be achieved with mandrel bending. I believe these are stamped into this donut shaped half for you to weld together. It's definitely good practice, maybe a cool wall piece, and then if you ever need a really tight radius bend, you can chop it in half. So let's take a look at these welds and I'll explain a couple little things to you. The main thing I want you guys to pay attention to on aluminum is that you always have a slight fisheye. As long as it's not a pinhole through to the penetration, it's not to be worried about. And if you do pick up one of these donuts, I recommend not welding the inside until you get them cut apart. It's pretty difficult. I also went ahead and cut up one of our round pieces. You can see here, I made a mistake and didn't penetrate quite enough on the startup of this weld, and I got a slight fisheye on the inside there. That is something you want to try to avoid because that can lead to future cracks. Right here, you can see maybe I stuck my filler in a little too far or something, as well as right here. And we've got a little bump, not as big of a deal. You can sand that down, it won't be any issue. That's pretty much what you want your penetration to look like. Of course, minus the fisheyes. And on the outside, we're not too bad either. You can see the fisheye on this one is maybe a little excessive. You can always go back and touch that up with a cool dab of filler to close that up as much as possible. I hope this video helped you understand a little bit better how to weld aluminum, made you a little less afraid to do it. If you guys are looking for more how to weld videos, how to perfect your techniques, check out this playlist, and I will see you in the next one.